how you doing? Myself, Joy Tribbiani from Friends. Okay. Hey guys, how are you doing? Myself, Harsh Pamar. So, welcome back to the channel. And that was a joke. I am not Joy. I'm Chandler, maybe. I don't know. So, I have come here today with a new and fresh video of how to reverse a doubly linked list, right? A doubly linked list is actually one in which a node contains three parts: a data part, a next pointer, and a previous pointer, right? So I'll suggest you to watch the video of reversing a singly linked list first if you have not seen it yet, and after seeing that video I'll suggest you to continue this video, right? So we'll just see how to reverse a doubly linked list. We'll understand everything, the algorithm, approach, code, right? So let's get started. So let's understand the algorithm of the problem. Now, every node in a doubly linked list consists of three parts. This is the data part, the middle part. This is the next pointer, and this contains the previous pointer. So for every node, the next pointer points to the next node in a linked list, and the previous pointer points towards the previous node in a linked list, right? It's pretty simple. So let's imagine that we have been given a linked list where nodes contain values 1, 2, 3 and 4, right? So the next pointer of 1 will point towards 2, the next pointer of 2 will point towards 3, and similarly the next pointer of 3 will point towards 4, and the next pointer of 4 will point towards null because there is no node after that, right? And the previous pointer of 4 will point towards 3, the previous pointer of 3 will point towards 2, and similarly the previous pointer of 2 will point towards 1, and the previous pointer of 1 will point towards null, right? Because there is no node before 1, hence its previous pointer will point towards null. So this is actually the structure of a doubly linked list where every node has a next pointer pointing to its next node and a previous pointer pointing to its previous node, right? So since this pointer is the next pointer of 1 pointing towards 2, so let's call it 1 dot next, that is, let's denote it by 1 dot n, that this is the next pointer of 1 which is pointing towards 2, and similarly this is the previous pointer of 2 pointing towards 1, so let's denote it by 2 dot p. Let's give it a notation 2 dot p, that this is the previous pointer of 2 pointing towards 1, right? So our task is to reverse the doubly linked list. Now what does actually reversing mean here? Reversing actually means that if you have 1 and its next pointer point towards 2, so in the reversed linked list the next pointer of 2 should point towards 1, right? So here actually it was the next pointer of 1 pointing towards 2, here it should be the next pointer of 2 should point towards 1, right? And in our original linked list the previous pointer of 2 was pointing towards 1, right? So in our reverse linked list the previous pointer of 1 should point towards 2, that is, this should be the previous pointer of 1 pointing towards 2. So this is actually what we need to achieve, right? So in short, what are we gonna do? We are going to traverse through the entire linked list, and for each node that we encounter, we are going to swap the values of its next and previous pointers, right? So we are going to iterate through the entire linked list, and for each node that we encounter we'll swap the values of its next and previous pointer, and in this manner we are going to obtain a reverse doubly linked list. So that was pretty much simple to understand, right? So We'll see what to do in the coding part. So let's jump to the code of the problem now. So let's discuss the code of the problem. Now, since this is a question of doubly linked list, right? So our first and foremost task should be to create the structure of a node. So let's do so. So let's define a class node. And I already told you that every node in a doubly linked list contains three parts. This middle part is the data part, this is the next pointer, and this part stores the previous pointer, right? So let's define a data part, a next pointer, as well as a previous pointer, right? We also have to initialize these values. Let's take a constructor and let it take a parameter data. So let's initialize this dot data is equivalent to data. Now you all can see this parameter's name is data and our variable name is also data. So just for the sake that the compiler does not confuse between these two names, that which data value will be going in which value, hence we use this keyword this. So this dot data is actually referring to this part, our variable, right? And this data is actually referring to this parameter. So the value of the parameter is actually going into our variable, right? So this dot data is equal to data. So in the same manner, we can initialize our next pointer to null, and we should also initialize our previous pointer to null. And by doing so, we are done. This is the closing parenthesis of constructor, and this is the closing parenthesis of node class. So we have created the structure of a node, right? So now come the actual part. Let's create a function, right? Public static. Now what should be the return type of this function? See, we have to reverse a doubly linked list, but in the end it still remains a linked list, and we'll return its head. So what is the data type of head? Head is actually a node type data, right? Hence the return type of this function should be node, right? And let's give this function a meaningful name, like reverse DLL, doubly linked list, right? And what will it accept? It will accept the head of the linked list, of the doubly linked list, which we want to reverse, right? Now first of all, we have to look for a very important base condition. We have to check if the head of the linked list that we have obtained is null, meaning the linked list is empty, right? Or the next of head is null, meaning the linked list that we have obtained contains only one node, right? So what are we gonna do here? We are just gonna return head and nothing else, because let's suppose that your linked list is empty, it does not contain anything, and you are asked to reverse it. So what will you return? You cannot return anything, of fruitful information. So you will just return the head, that is null. And if your linked list contains only one node, that is the head node, so reversing one node doesn't make any sense, right? So just return the head node. Now since we have already discussed in the algorithm that in order to reverse a doubly linked list, we have to traverse through the entire linked list, and as soon as we encounter a node, we will have to swap its next and previous pointers, right? So let's suppose you have a linked list containing these four nodes. So this is the next pointer of 1, this is the next pointer of 2, that's the next pointer of 3, and the next pointer of 4 points to null. In a similar manner, this is the previous pointer of 4, this is the previous pointer of 3, this is the previous pointer of 2, and finally this is the previous pointer of 1 pointing towards null. So at every node that we come across, we'll swap its next and previous pointers. So to start with, we define a current pointer and we make it point towards the head of the linked list. And we also declare a previous pointer and we make it point towards null, right? We will run a loop till this current pointer reaches this end null of the linked list, till this point. And as soon as the position of current pointer increases and it traverses across every single node of the linked list, we will swap its next and previous pointers, right? So first of all, as we all know, what's the mechanism to swap two numbers? Now let's suppose we have two numbers a and b and we have to swap their values. So what's the code that we actually implement? We store the value of the first number in some temporary variable c. Then we make the first number equal to the second number. Then we make the second number equal to the value of the temporary variable, which actually holds the value of the first number. So in this series of steps, the values of a and b get swapped. That is, a and b can be swapped by taking a temporary variable, a c variable. Now suppose our current pointer is pointing at this node initially. So what we desire to do, we want to swap the values of the previous and the next pointers of current. That is, we wish to swap the values of previous of current with the value of next of current. So what we do, we take a temporary variable and name it as previous, right? You can give it any name. I am giving it a name as previous. So in previous, I will store the value of the previous of current, right? So what is the previous of current? This is the previous of current, that is initially it's null. So in previous pointer, I will store the value of null, right? Now what I will do, I will make the previous of current equal to the next of current, right? So this was the link of previous of current. So this link gets deleted from here and the previous of current now points to the next of current. So this is the updated previous of current, and previous was 1 in this case, current was 1 in this case. So this becomes 1 dot p, the previous of current, right? Now the next of current has to be updated with previous. So this new link gets created, which becomes the next of current, and this old link gets destroyed, right? So in this manner, we have actually swapped the values of the previous and next pointers of current. We have, used a very simple algorithm of just swapping two numbers. We have taken a temporary variable previous. We have stored the value of the previous of current in the temporary variable. Then we have made the previous of current equal to the next of current. And finally, we have made the next of current equal to previous, which was actually holding the value of previous of current. So we have swapped the two pointers, current previous and next of current. And now moving further, we have to update the value of the current pointer, because this was our current pointer and its previous and next links have been swapped, right? So now we wish to update its position. So current becomes equal to the previous of current. So this is the new position of current, because this is now actually the previous of current, because we have updated the link of previous of current, right? Hence, to move this current pointer forward, we have to update it to the value of previous of current, right? So finally, current points at this node. So now repeating the same steps once again, the previous pointer will store the value of previous of current. So this is the previous of current, because this is our current pointer. So this is the previous of current, and the previous pointer stores this value and this gets deleted. Now we will update the value of the previous of current with the next of current. So the previous of current gets updated with the next of current. So this becomes the new previous of current, and this old previous link gets deleted. And finally we have to update the value of the next of current. The next of current becomes equal to previous. So this becomes 2.n, the next of current, and this old link gets deleted. And finally we have to update the value of current pointer. Current becomes equal to previous of current, and this position gets erased. Right now, following same steps once again, this is the current pointer and this is the previous of current pointer. So in the temporary variable previous, we will store the value of the previous of current. On doing so, this position gets deleted. Right now we have to update the value of the previous of current. So previous of current becomes equal to the next of current. Hence this was previous, the previous of current becomes equal to the next of current. This becomes 3.p, and this old link gets deleted. And finally the next of current gets updated to previous. So this is the next of current, it gets updated to previous. So this is a new link created, 3.n, and this old link gets destroyed. And finally we have to update the value of current pointer. So current becomes equal to the previous of current, because this is now the previous of current node, right? So to move current one step forward, we have to update it to the previous of current. And finally this old position of current pointer gets deleted. Again, following the same algorithm, we will store the value of the previous of current in the previous pointer. So previous pointer now points here, and this value gets deleted. Then we will update the previous of current to the next of current. So this was the previous of current, now it points to the next of current. So this is the previous of current, right? And the next, and by doing this, actually this link gets deleted. Right now we update the next of current, which becomes equal to the previous. So this becomes the next of 4, right? And this old next pointer gets deleted, right? And we move current one step forward. So to move current one step forward, we have to make it equal to the previous of current, because this is the node of the previous of current, right? So this position gets deleted. Right now we notice that our current pointer has reached to the end null of the linked list. So at this point of time our loop will get terminated and our process ends. Our loop gets terminated because this was the actual condition till which we were running our loop. That is, we were traversing the entire linked list till the current pointer reaches the end null of the linked list. And while traversing the linked list, we have swapped the values of the next and previous pointers of all the nodes that we have encountered in between, right? So our task has pretty much been finished by now, and now you can actually see that all the links have been reversed. That is because if we look at the initial linked list, so this was our initial linked list. So we already saw that the next of 1 was pointing to 2, the next of 2 was pointing to 3, the next of 3 was pointing to 4, and the next of 4 was pointing to null. So initially every number's next was pointing towards its higher number, right? But here in this case, every number's next, so let me use a different pen, every number's next is pointing toward its lower number. That is, next of 4 points to 3, next of 3 points to 2, next of 2 points to 1, and 1 points to null. So next of every number point to its lower number. And similarly, in the initial linked list, every number's previous was pointing to its lower number. that is previous of 4 points towards 3, previous of 3 points to 2, previous of 2 points to 1. So every number's previous was pointing towards the lower number, and in our updated linked list every number's previous is pointing towards the higher number. So previous of 1 points to 2, previous of 2 points to 3, previous of 3 points to 4. So we have reversed, we have swapped the previous and next links of all the nodes. Hence we have, reversed, we have swapped the entire linked list, we have reversed the doubly linked list, and our task has been achieved. And finally, what are we gonna return? So we are gonna return in the end the previous of the previous pointer. So let's understand this logic. What is previous of the previous pointer? So if we see in this updated linked list, this is our previous pointer, right? It points to this position. And what is the previous of previous pointer? This is the previous of the previous pointer, because this was 3, and what's the previous of 3? Previous of 3 is pointing to 4, right? So this node is actually the previous of previous pointer, and when we return this node, it is actually the head of the updated, the reversed doubly linked list, right? So we return the head of linked list every time when we perform any operation on it, right? And we can traverse through the entire linked list by just doing next operations on consecutive nodes. So we return the head of this updated linked list as well, which is this 4 node. And how can we actually come across it? By returning the previous of the previous pointer. So previous points here, and previous of previous pointer points here, which is actually the node of the updated linked list. So simply return it. So this was very much the algorithm of the problem, and it was pretty simple. Just you have to understand how to swap the links. So now let's come to the coding part. So we had already coded this till this part, that if our linked list is empty or it contains just a single node, so we'll return the head of the linked list. So after this part, the next part follows. So we'll first declare a current pointer and initialize it to the head of the linked list, as we saw in the algorithm above. We will also declare a previous pointer and initialize it to null. Then we will run a loop till our current pointer reaches the end null of the linked list, right? And now what do we have to do? We just have to traverse across the linked list, and as soon as we encounter any node, we have to swap its previous and next parts, right? So let's store the previous of the current in some temporary variable previous. So previous stores the value of the current, the previous pointer of current. So now let's update the previous of current to the next of current, and let's update the next of current to previous. So previous actually stores the value of the previous of current. So next of current finally holds the value of the previous of current, right? And we have to move our current pointer one step forward. How can we do that? By updating it to the previous of current, right? This also we have seen in the algorithm. So what are these lines doing? These are just swapping the values of previous and next pointers. So that's the only motive of these lines, because this is our swapping algorithm. T equals A equals B equals T. So if we have two numbers A and B, so with the help of a third variable T, a temporary variable, we can swap these values. So this is what we have done here in this case, and in the end we are just going to return the head of the updated linked list, and the head can be obtained by doing the previous of previous, which I have already explained in the algorithm. You can rewind the video and see it once again in case you have not got it. So our code has been finished. So let's talk about the time and space complexities of the problem. So time complexity is definitely of the order of n, because to achieve our answer we have to, if there are n nodes in a linked list, we have to traverse through all the n nodes, right? So time becomes equal to the order of n, and space complexity is just a constant factor of the order of 1, because we haven't used up any extra space, in finding the answer. We have not used any extra data structure like array, stack, queue, which could have taken up some space, right? So yeah, this is pretty much it. Time is of the order of n and space is of the order of 1. So this was all about the problem. It was a pretty simple problem. I hope all of you might have understood it. So guys, that was all about reversing a doubly linked list. I hope all of you might have understood the concept and logic of the problem now. So we'll meet once again with a fresh and new video. Till then, I'll take your leave. So take care, goodbye, thank you, and happy coding.